Hi all. In this session, we are going to cover session management function or SMF overview. So, in a 5G service-based architecture, we rely heavily on control and user plane separation, that is CUPS, and SMF represents the control plane for all user data, and it doesn't process the user data packet itself. Rather, it sets up the rules, the path, and the policies for those packets. So it is responsibility is divided into four major categories like session lifecycle, user plane control, policy and charging, and then mobility and roaming. So now, first of all, when a UE kind of request an internet or private network access, the SMF is going to create end-to-end data connection between UE and external data network. And during this setup, it acts as a IP administrator, like assigning and managing the IP addresses. You can say IPv4 or IPv6. So the UE can actually route traffic to the network. And also, here, you can say networks are dynamic, and if a user service needs change, and perhaps they launch a high definition video call, and for that they require some better QoS. So SMF is going to update those existing session parameters and routing policies on the fly. Okay, and finally, when the session ends, SMF can tear it down and ensuring all state information is cleared and valuable network resources are released back to the pool. And before, because of the cups, SMF must orchestrate the physical routers. You can see the UPF to move the actual bytes. So here, SMF has the intelligence to select the most optimal UPF for a specific session based on the location, load, or network slice requirement. And once selected, SMF configures the traffic steering, you can say, at the UPF. So it is going to provision the exact packet forwarding rules to ensure traffic reaches the proper destination. And also, it does all of this over the high critical N4 interface using that PFCP, that is packet forwarding control protocol. And here, PFCP in here, you can say SMF is kind of the master, and UPF is kind of the forwarding node. Now here, the SMF is doesn't make up the rules, so it only enforce them. Okay, so here we have PCF, and SMF is going to talk the PCF to retrieve the subscriber session rules. It then translate those high level policies into actionable QoS and kind of enforcement rules for the UPF to execute. And next we have charging function for billing SMF interface with the CHF, and it is going to enforce data quotas. For example, capping a user at some 5 GB and collect granular data usage metrics so the operator can bill accurately. Then we have lawful interface. So from the regulatory standpoint, SMF provide the secure control interfaces needed to configure the UPF to silently, you can say, mirror user traffic for authorized surveillance, and hence ensuring legal compliance. And also SMF plays a massive role in keeping the user connected while on the move or roaming. So here we have downlink data notification and paging. So if a UE goes into an idle state to save battery, UPF won't know where to send incoming packets. So UPF notifies the SMF, and SMF alert AMF to page the device, waking it up to receive that particular downlink data. Also, it has to determine the SSC mode, SMF determine SSC mode, mode 1, mode 2, or mode 3. And this dictates whether an IP address is kept stable or changed as the user move, which is kind of critical for edge computing and ultra low latency application. Also, it is used for roaming, for international or cross network roaming. SMF manages the routing policies. It determines whether the traffic should be rolled out locally or via the visitor network known as LBO, or kind of it tunnel all the way back to the user home country via asset architecture, you can say. And to wrap up things, like here SMF is the kind of ultimate orchestrator of the 5G data path. So it provisions the IP, select the UPF, enforce the PCF policies, report to the CHF for billing, and ensures continuity as the user moves. And that's it for this particular session. I will see you in next session. Thanks.